on brandy technology. But you're also no doubt aware that in the expanded course description catalog, or the mini catalog put out by the college, that the title is now indicated as Distilled Beverage Technology. The reason for this is that about a year ago there was a course change form put through that was approved a little too late for inclusion in the general catalog. The reason for this change was that some of the staff and a committee decided that this newer title would in the sense of broadening the scope of distilled spirits treatment, would perhaps serve as a basis for interesting people outside the wine and brandy industry into our programs here, possibly therefore generate some not only student interest but possibly financial support. Now whether or not this will ever work out or not is another question. There's always some devious purpose to most all changes, you see. So this will have very little effect on the course as given this year from what it was in the past year, because in reality I've been including some treatment of spirits other than brandy in my discussion for purposes of comparison and similarity, treatments about distillation procedures for production of whiskeys of various types. Perhaps we'll cover a little bit about production of gin and rum and liqueurs before the course is over. Well, as most of you know, my name is Guymon, and my office is down the hall, room 1001. I'm generally available for consulting at most any time that I have available. But if you'll notice on my door card that I've indicated that my hours for visiting or consulting is primarily on all day Mondays and Fridays, and Tuesdays and Thursday afternoons. It looks like I'll be engaged in teaching all day Wednesday, so I normally won't have that as a office hours. Well, perhaps you might be interested in just a little bit of my background so that you'll know what to expect from me. I was trained as a chemical engineer in my undergraduate days. And after that, I worked a couple of years in an industrial concern, which, namely Commercial Solvents Corporation, which at that time produced spirits, but they also produced solvents by fermentation and distillation. So my first practical experience in distilling stems from the 2 years I had in an industrial background. Following that, for graduate work, I majored in a program called biophysical chemistry. Now this largely was concerned with fermentation processes for producing chemicals, including ethyl alcohol, but other materials, products of fermentation also. So I guess that was the kind of a background that the chairman at that time, Professor Winkler, thought would be useful in this department. So I joined the University of California here at Davis in 1939, and except for a 5-year stint in the Army during the war, I've been here ever since. So my specialty has been distillation and brandy as far as the research projects are concerned. But rest assured, I know a certain amount about wines and I have a considerable experience in that, and I hope that some of the material we have in this course will be useful in your careers in wine making, enology, however it may turn out. Whether or not there's any distilling aspects involved in your work or not. I might mention that I'm aware that I'm not the most inspiring formal lecturer in the department or in the university, but I prefer to have a sort of discussion rather than formal lectures, but we will have generally lecture outline to follow. I also mentioned that my hearing is a little bit less than acute, so when you ask questions, well, it might help if you don't mind speaking out pretty well so I can understand. Now, the first thing I think of the order of business would be to verify who's here from my registration list. And so I think I'll just go down the list here, see how many how many are here. And the statements made there. The course goals stated here is to learn the fundamental principles of, and I might say practices of distillation, and, well, applications to the processes used in the production of dessert wines, brandies, whiskeys, and other distilled beverages. And secondly, to further the student's ability to use quantitative concepts and deductive reasoning for rational solution to practical problems. This last statement follows from my background, I guess, of having some exposure in engineering. And in fact, I have participated in teaching food processing courses, concerned with engineering process principles. So, an adequate understanding of a process such as distillation requires a certain quantitative treatment. And since I have the impression that many of the courses are not particularly oriented toward engineering concepts or mathematical treatment of the processes that we want to emphasize in this course. So we'll have problems to work, mostly numerical problems. Several of those I'll ask to be handed in for grading. The purpose, of course, of that is to illustrate some principles that we want to get across and make sure you understand it. I'll come back to that point in a moment. Now, there's no text required. I had suggested that, particularly for those who are interested in having some text available, concerned with to cover the principle of distillation, the book by Van Winkle, entitled Distillation by McGraw-Hill, is recommended. Admittedly, this book is somewhat too advanced for the scope of distillation that we intend to cover, and is primarily for chemical engineering students. But apparently it's available in the bookstore, and it does include some of the material, or much of the material that we'll cover in as far as discussing distillation principles are concerned, and distillation design. But I will have many handouts of material that will be to be covered in lecture periods in the lab, and also reference tables of data that I'll hand out for your records or use. The entry level here is stated to have an understanding of organic and analytical chemistry. When we wrote this up, they were trying to get us to omit formal prerequisite requirements. Normally that would include Chem 5 and Chem 8. And then it's added on here, recommended physical chemistry, where so to include the thermodynamic properties of solutions, vapor pressures, and vapor-liquid equilibrium. Now, I realize that probably the most of you have not had that. You may have had some of it in general chemistry, or even in Chem 5 or 8 may have covered some of that. I guess it probably does. But anyway, we will review those principles and take them up because an understanding of that is necessary for an understanding of the distillation processes. We've already mentioned the course format. We'll probably have 2 or possibly 3 midterm exams and a final. And some graded problems and perhaps a few, 2 or 3 or 4 lab reports to be handed in to be graded. Some people are interested in what kind of a formula I use for calculating grades. Well, I suppose I would say that if we have 2 one-hour midterm exams, the average of that will be about 45% of your grade, and the final will be about 45%. And homework and lab reports, maybe your attendance record would constitute approximately 10% of the final grade. If we might have some exam, might have an exam that was appeared to be unduly easy or unduly difficult based on the class average, I might take this into consideration and giving a little lesser weight to it, especially in the event I give a 3rd midterm. I'm inclined to give minuses and pluses to final grades when they're on the borderline. Out of 17 last year, I think I gave 7 that had a plus or a minus on it. And generally speaking, A's would be 90 or above, and I think the A minus's break point was about 87 or 88. I forgot where it was. And B's 80 or more, and so on. Well, you see here the subject materials that we propose to cover. This is not necessarily exactly in the order in which they'll be taken up, and doesn't mean that a single lecture period will be devoted to one of these subjects and we'll go on. Some of these subjects will take more than one period. So this is an indication of the material we hope to cover in the class. Also, the laboratories periods will tend to follow this outline here, but some of these may take more than one period. I think we have, I don't know whether we have 10 or 11 laboratory periods, perhaps 11. But we hope to cover, have some practice in all those 9 subjects mentioned here. So let's see, any questions about this?
What kind of field trip is that?
Pardon?
What kind of field trip?
Well, we'll probably take a trip to Lodi to visit a couple plants down there, one of which will be distilling. We'll just show distilling, maybe the production of distilling material and distilling. And we'll probably visit the guild cellars where they have 2 large warehouses, so we can see the warehousing and the processing for brandy out of the warehouses and the bottling line, and that'll be probably the field trip we'll take. Now, a few points I want to make here about expanding on the course objectives or the course format. As I've already mentioned, to understand the fundamental principle of distilling, which is a separational process, we need to consider some aspects of column construction or still construction, such as the number of trays to affect the given separation or concentration, a little bit about the importance of tray spacing, column diameters for a given load or given requirement, or if we're this would be approaching it from a design standpoint. Now, frequently we are interested more in applying or understanding the processes that go on in an existing design. You go out into a plant where distilling is carried out, there will be an existing column. You may or may not ever have occasion to participate in the design of any new equipment. But you very likely may have the opportunity to participate in the operation of equipment that's on hand. And so an understanding of how the physical aspects, dimensions and so forth of distilling columns pertain to the operation is quite essential to understanding what's going on, or an intelligent approach to the use of the equipment. So this requires an understanding of the behavior of solutions or mixtures. That is, we'll be talking about the concept of vapor pressures, boiling points, the behavior of azeotropic mixtures, or that is constant boiling mixtures, partially miscible mixtures, and in general the behavior of minor constituents of wine, that is the behavior during distilling processes. Most of our examples we'll be using, which will have any quantitative concept, will be emphasizing the ethyl alcohol water system, and we'll give you all the features about that we have available. There's the physical, chemical, and thermodynamic properties of ethyl alcohol water as a binary system, and how minor constituents behave in reference to the alcohol water percentages. Now, then of course we'll be taking up some aspects that may be more descriptive, having to do with the technology of brandy production, or a concept of the recommended procedures and practices to be used. Now, as far as the technique of this is of teaching and conduct of the course, I would say that we'll generally be using the English engineering system for quantitative relationships. This means our units of measure consist of pounds, cubic feet, gallons, possibly foot-pounds of force, and so forth. We'll also probably have occasion, to measure concentrations and quantities in terms of moles, or pound moles. Now, this is maybe a little bit ironic in the present time when there's a considerable discussion about going over to the metric system, and that which you've used mostly in your other courses, I imagine, or in other words, grams and milliliters and seconds, or sometimes called the CGS system of units of measurement. But the fact is that if if you go into the wine industry, you'll be using the units that I've mentioned, the English engineering system, the English units of measurement. And so there's a certain amount of a conversion of units that you will have to be able to make, have to be able to convert from grams to pounds and from gallons or from cubic centimeters or milliliters to gallons and so forth. What was your question?
Yeah, do they still use the English system in the laboratory? Like, do they measure in ounces, pints, instead of milliliters and liters?
Well, you'll find in the wine industry you have a mixture of that, and that's the reason you have to have some practice and adeptness in converting back and forth. Most of the times, well, like determining alcohol, your typical unit of measure is percent alcohol by volume, or proof, percent of proof. But other constituents you determine by titration or other methods, and you come out with grams per liter or parts per million, that sort of thing. So the ability to make the conversions, which is not too difficult, but it requires a little practice, is what we will have occasion to do. Now, a lot of the problems that we'll use or involves, as I mentioned already, a quantitative approach to the solution of problems, operational problems. Now, this is not any particular different than stoichiometry in chemistry, where you balance an equation, use quantitative calculations based on a balance. But we will have some occasion to review with you the concept of applying material and energy balances to the solution of problems. In much of the processing that we would be discussing, we'll have what we call a continuous process or a steady state process, where after you get the process into operation, you'll have a certain rate of input to a process and certain products coming out. Well, if this is on a steady state process, there's no accumulation or diminution of the materials in the process, but what goes in comes out at the same rate, and maybe in different form or different concentration, different concept. So that would be a concept of material balance. A complete understanding of distillation processes involves a certain familiarity with energy balances. And so we'll have a little bit of exposure, at least, to equating the energy input to the energy output. And these are two rather elementary techniques that's typical of engineering processes, the material balance and energy balance. And they simply follow from the material balance from the law of conservation of mass, where mass is neither created nor destroyed. Of course, in atomic energy in our atomic energy period, there's some exceptions to that, but our processes will not involve any significant atomic energy changes. And of course, the concept of energy balances is simply a continuation of the concept of the first law of thermodynamics, that energy is neither created nor destroyed by whatever processes it goes through. We will have occasion to use graphical representation of data and graphical methods of problem solving in a few cases, where algebraic solutions are either impractical or impossible. This is a fairly typical engineering or industrial technique that is used and required. Many times in industry, it's impossible to be completely rigorous in a particular situation, so you have to use some simplifying assumptions. They should be either logical or justified. There are some times that we have problems to meet up with where a direct solution is not very feasible, so you may have to use trial and error. You make an assumption, make a solution, and see how close it comes out to what it has to be. And then by that result, you can make a slightly more intelligent second assumption and go through the process again. So you can narrow it down to the point where the solution is exact by trial and error. This is not maybe very satisfactory and usually rather lengthy type of solutions, but sometimes in industrial processes, engineering problems, it's necessary. As far as materials needed in the course, primarily you need a loose leaf notebook to collect the handouts I'll give you and the problems. And hopefully you're either familiar with or have a slide rule, or maybe by now you've got a pocket calculator. Last year I indulged myself in one of these electronic pocket slide rules, and I find it very useful. The price has already come down $30 from what I paid, so they're quite reasonable now, but there's still some things I need a slide rule for anyway. Well, I think in the few remaining minutes, unless there's any questions at this point about what I've been talking about, I'll mention that tomorrow, for the laboratory period, we'll plan to do a little practice in measuring the alcohol content or proof of alcohol water solutions, with some practice in the use and applications of the gauging manual. The gauging manual is a publication of the U.S. Treasury Department and includes several very useful tables, which are much used in the process of determining the quantities of spirits, determining the concentration of alcohol in the spirits, and determining the quantities, either by a volume basis or a weight basis. Along with that, we'll have some divided in smaller groups, and we'll have tour demonstrations of the various types of distilling equipment that we have in our pilot laboratories here. And so, for the remaining part of this hour, I think I'll mention a few definitions that you may or may not already know, having to do with alcohol. And the first term that you probably know by now is called proof. And, proof is defined in the United States well, perhaps we should say percent of proof, is simply equal to the percent alcohol by volume measured at 60 degrees Fahrenheit multiplied by 2. That means then that a solution containing exactly 50% alcohol by volume is 100% of proof, or what we call proof spirit. A little later I'll have available to hand out for you some tables here which include methods of converting percent alcohol by volume to percent alcohol by weight or to percent alcohol by mole. And also there's a little bit of explanation in here about the differences in the concept of proof as applied in the Great Britain and countries that use the British system of proof, but I won't go into that today. Except to say that proof spirit is in the Great British system is approximately 57.1% alcohol by volume. Is that right? Now, we use the term wine gallons in the distilled spirits industry to differentiate from proof gallons. So wine gallon is simply, or a gallon is simply a volume occupied by 231 cubic inches. And generally it's defined at 60 degrees Fahrenheit. Because as you're aware, liquids contract or expand with temperature, so 60 degrees is the standard temperature used in the legal aspects of distilled spirits considerations. So a wine gallon is simply 231 cubic inches measured at 60 degrees Fahrenheit. Fundamentally, and lots of times it's not that critical, so you don't worry too much about a few degrees differences. But a proof gallon is the term that we use, and perhaps the simplest definition is to say that it's one wine gallon containing 50% alcohol, or one wine gallon containing 0.50 gallons of pure alcohol. So in other words, it'd be 1 gallon at 100 proof. On the other hand, it is also defined as any quantity which contains the equivalent amount of alcohol equal to 1 wine gallon at 100 proof. Now maybe, did I say that not very well? Well, you could say it another way. It's any quantity which contains 1/2 gallon of pure alcohol. Exactly 1/2 gallon of pure ethanol. But it's very easy to determine the number of proof gallons if you know the percent of proof is equal to wine. You multiply the number of wine gallons that have by the percent of proof divided by 100. For example, if you have 100 gallons at 170 proof, how many proof gallons would you have? Let's hear it. 170. 100 gallons, and I maybe should say wine gallons. 100 wine gallons at 170 proof. The proof gallons then, which we frequently abbreviate PG, would be equal to 100 times 170 over 100, or 1.7, or 170 proof gallons. So in other words, it's very easy to determine the number of proof gallons if you know the volume in wine gallons and the proof. And so part of the problem of gauging is determining first of all the proof, the concentration of alcohol, and secondly the volume. Now frequently we determine the volume not by actually measuring the volume but by weight. It used to be that gauging of spirits for tax purposes, well, I guess it's still true. The gauging of spirits for tax purposes is still done by weight. However, the gauging of spirits for processing in the sense of barreling down brandy or measuring spirits out for fortifying wine is now done on a on a volume basis normally. Several years ago, when I first came into the business, well, even for fortifying wines, you had to measure it out by weight. Had to have tank scales, measure it by weight. So you can do it either way. And of course, tables in this gauging manual give the factor by which you multiply or divide a weight of a given mixture to get wine gallons or proof gallons. You'll see that this manual has very many useful tables that can be applied under most all kinds of situations for determining the contents. And finally, I'd mention one more term. That's the term tax gallon. And that's the unit of measure which is the basis for applying the imposition of tax, the Internal Revenue tax on distilled spirits. And if the spirits to be gauged are 100 proof or more, a tax gallon is exactly synonymous with proof gallons. If the proof of the spirits to be tax paid are less than 100 proof, then tax gallons are exactly equal to the wine gallons. This comes into practice particularly in the importation of spirits that are bottled overseas. The bottling of brandies or whiskeys are usually less than 100 proof. Scotch whiskey typically 86 proof. Cognac brandies or Armagnacs typically 80 proof. So the way the law presently reads, they have to pay tax on the number of liquid gallons imported, not the proof gallons. The importers and the exporters from foreign countries have tried to contest this application, but so far unsuccessfully. Yes?
Does that mean it's cheaper to bring in overproof spirit than underproof?
If I understand your question correctly, this tends to favor the practice of bringing in spirits at a greater than a 50% alcohol, which means it tends to favor the importation of spirits in bulk and then later reduction in this country to bottling strength because they avoid this penalty, so to speak, on tax gallons. The tax gallons, if it's imported in bulk at a high proof, above 100, well then they get the benefit of paying on the number of proof gallons. But if they bring it in bottles at 80 proof, they get they have to pay in effect 20% more tax because they have 20% fewer proof gallons. I always thought that this was a little bit of a unfavorable factor, or a factor which tends to mitigate against the quality spirits. The quality of the famous brands imported, the producer hopes to or prefers to and does bottle on his own premises and then exports it at the bottle strength. But this course gives them a involves this tax disadvantage, so that it tends to favor the importation of spirits in bulk. So a good part of the imported whiskeys and some of the brandies sold at retail in this country are imported in bulk and reduced here and bottled in this country. Well, period is up. And are there any particular questions, quick questions about any of this?
Will there be an afternoon lab tomorrow?
Well, I'll try to take these cards and be sure to hand these in and try to work it out. Now, I would like to have an afternoon lab tomorrow if I can get 10 or 12 people assigned to that lab. But anyway, since you're all scheduled to come at 8